Alright, so moving on to section 2 of chapter 2, we're going to be looking at some basic algebra stuff, and then it's going to lead us into what's called the difference quotient. Okay, and the difference quotient is fairly important for what we're going to be doing. Okay, so let's say we have these functions, and we have our f of x and our g of x. So now the question is, what would f of x plus g of x be? So with this, take a second and combine f of x and g of x. So when we add f of x and g of x, basically all we're doing is we're taking our f of x, whatever it might be, and we're adding it to our g of x, x minus 8. And we're combining them. So now we combine like terms, combine the x's, and then combine the constants, and we end up with 3x minus 6. And that would end up being our answer with this. All right. Okay, so whenever we have these functions of f of x and g of x, we want to make sure they're in the same domain. So if they're not in the same domain, then that means we can only combine these, multiply them, add them over the overlapping domains. So if the f's domain was from 0 to, let's say, 10, and then the g's domain is from 5 to 15, anytime we use the combine, if we combine them, we can only use the domain of 5 to 10, because that's the only overlap we have. We don't have anything in between. So when we're adding them, f of g of x is the same as f of x plus g of x. F minus g of x, f of x minus g of x, you're just subtracting. You can multiply them together, so fg of x, and then f over g of x is the same as dividing, but make sure that the g of x does not equal 0. Okay, so now with this, we can also take it with a graph. So you can be given a graph, and you can be asked to identify the missing parts of it, or adding and subtracting. And so what we would do is you're basically finding what is the y values, and then whatever operation you're doing with the f and g, that's what you're doing with the final one. So here we have f of x is 2, g of x is 5, and since we're adding them together, we would go 5 plus 2 gets us up to 7. So the new function's at 7. Then we'd go on to the next main point. Okay, so we've got 1 and 3 getting us 4. Here we've got 3, 4 getting us 7, and so on and so forth. Okay, so that's what you would do along the whole thing. If you're subtracting them, you would subtract them. If you're dividing, you would divide, etc., etc. Okay, only in the parts that overlap. If you have one part that goes a little farther than the other one, then it would not. You wouldn't do anything with that part. You're only looking at the overlapped. Okay, so here's your f of x and g of x as given above, and so we're going to go f minus g of negative 4. Now what this negative 4 does is it means you plug that number into the x's of each function, okay, and then you simplify it. So one way of doing it is to combine them, plug that number in and then simplify it, or you could simplify the x's first and then throw a negative 4 in. So with this first one, if we take that negative 4 and plug it into the first one, it'd be negative 4 plus 4. And the second one would be the square root of negative 4 minus 1. And we'd simplify each one. The first one would end up being 0 minus the square root of negative 5. And since we can't take the square root of a negative, it ends up being an imaginary number. We only really want real numbers. We would say that it does not exist. Okay, so take a second and solve the rest of these. They're either going to come up as a solid number, a number, or it's going to come up as does not exist. Okay, either because it's undefined, negatives in the square roots, etc., etc. So take a second and solve the remaining 5 on this. Okay, so with this, let's start with the first one of f over g of 1. So you would plug a 1 in for all of them, and you end up with the square root of 0 over 5, which ends up being 0. So that first one ends up being 0 because the g of x, or g of 1, makes you 0. G plus f of 1, so we plug in our numbers and we end up with 5. because the g of x, or g of 1, ends up being 0 again, while the other one becomes 5, and you're adding them. Now the multiplication, so when we're multiplying them, okay, so g times f, we would plug a 10 in, so the g, if we plug a 10 in for g, we end up with square root of 9, which is 3, and we multiply that by 14, getting us a 42. Next one, f over g of 1. So plug in a 1, we end up with 5 over 0, which means it does not exist. And the last one, f times g of 3. You plug a 3 in to the f, and you get a 7. You plug it into g of x, and you get a square root of 2. So we got 7 square root 2. Okay. All right, so that's solving those. Okay, so let's say we have a curve. So we're looking at this, we're looking at the red curve here. And the red curve has this green line cutting through. What we'd want to do is want to find what's the slope of this curve. Now, here's the thing with this curve is that as you move along, the slope changes. If you take the slope here, it's 1. If you take the slope here, it's different. If you take the slope here, it's different. So as you see, as you move along it, it increases. Okay? And so that's what we have to look out for. And so when we're asking for the slope, we'd want a slope at a single point. So this green line, okay, this green line is called a secant line. And a secant line is a line that crosses through a curve at 2 points or runs through a circle at 2 points. And that's a secant line. And what we could do if we want to find what the slope is that we could find the slope of a secant line. We pick 2 points on the circle, find the slope, and that's going to tell us what the kind of average slope would be over that time. The other line, that orange one, is a tangent line. A tangent line is the one that we want to really find because it tells us the slope at a given point. Okay, so it tells us the slope at a given point. Okay, so to find the slope between two lines, basically what we're doing here is that we're using the slope formula, which is y1 minus y2 all over x1 minus x2. And we're using that with our 2 points to find our answer. Okay, so if those are my 2 points, basically what's happening with this second one is that we're just saying, okay, if our first point was xy, we want to move a little bit away from x and y to find the slope. We want to be close to it, but we have to be a little bit, we have to have some distance from it. And that's what's basically happening here, is that this h is telling us how far we're going to move away from our original point. Now when we look down here, f of x plus h minus f of x all over x plus h minus x, this is just your slope formula. These are exactly the same. This is your y1, or x1, y1. This is your x2, y2. I mean, it's the exact same thing, it's just written a little differently with our notation that we have. Okay. Now, when we simplify the bottom, if we go back, if you simplify the bottom here, you end up seeing that it's x plus h minus x, which reduces down to x. This right here is called your difference quotient. Your difference quotient is used in calculus for a few different things, but it's a way for us to help us find something special about a function. So, let's say we have this function right here. F of x is equal to 4x plus 2. And we want to use this difference quotient to simplify it. So what we would do is that anywhere we have an x, we're going to replace it with x plus h. Okay, so we would end up writing it as 4 parenthesis x plus h plus 2. And now we're going to subtract it by the original, 4x plus 2. And divide everything by h. So now we'd multiply everything through and simplify it. I'm going to move up here and I'm going to simplify it. So when I simplify it, I've got 4x plus 4h plus 2 minus 4x minus 2. Okay. Simplify that all the way down. We end up with 4h all over h. When reduced, we end up with 4. So our difference quotient, when we simplify this, ends up being 4. Okay. So our difference quotient for this is 4. Okay. Now what's the slope of this line? f of x is equal to 4x plus 2. The slope is 4. And this equation is helping us find the slope of functions. So if the function always has a slope of 4, that means that our difference quotient should always be 4, in which we see here it is. Okay. All right, so now let's make it a little bit more complicated and use one slightly different. So we have this, which is more of a curve. Okay, it's a parabola opening upward. And what we want to do here is we want to do the same thing. We want to find our difference quotient. So everywhere that there's an x, we're going to replace it with an x plus h. So we end up with 2 parenthesis x plus h squared minus x plus h minus 3. And then we're going to subtract it by the original function. Now I'm not going to write it all the way out because it's just what's right above it. Okay. Now when we multiply out this part, we end up with x squared plus 2xh plus h squared. And so I'm going to multiply the 2 in there to get it. And now I'm going to distribute that negative, x minus h minus 3. And then we have a minus 2x squared plus x plus 3. And so I've distributed the negative into each one of those. Okay, and that's what's happened. And now we want to go through and simplify. Now the one thing that you should notice with this when we simplify it is that these right here should always disappear. You see they always match up. They're always opposite signs with another one. Oh, wrong one. Whoops. Erase. They're always opposite signs with another one. So you see they always disappear, leaving us with just our answer of 4xh plus h squared minus h. And then we divide all that by h. So now you see that we have some things that can be reduced. We have an h and everything on the top. We have an h on the bottom, which means that one or these h's can be reduced, leaving us with our answer of 4x plus 2h. Oh yeah, because this is a 2. Oops, there should be a 2 there. 2h minus 1. Okay, and that is our function. Now that function tells us the slope of the curve at any given point, but it gives us a formula. So we'd have to plug in our h, so how far we're taking our 2 points apart from each other, and we have to pick what our x value is. Because since this is a parabola like this, if I pick an x value right here, that's going to be a negative slope. If I pick an x value over here, that's going to be a positive slope. So the location in which I'm picking my slope is important. That's why we have a formula instead of just a single number. So anytime you have a curve, you're going to end up with a formula to find what it is, to find what the slope is. Okay. All right, so that's the end of this section. The difference quotient is probably the more important section in this. That is it for section 2.